All right, this video is going to help you guys get started on this Google Earth project. So first thing I want you to do is think of something really cool in Google Earth, a lake, a continent, a state, Vatican in Rome, or something really interesting in the world that you're curious about. So I'm going to pick the great state of Michigan, America's high five, and we're going to see if we can fit curves to this. So what I want you to do is screen capture what you think is going to work, and then throw it in Smart Notebook. Okay, so I've done that here. Now there's 6 mandatory curves that you have to fit to this. So this is just an idea to see if your object's going to work. So I need a square root. So if I look at the boundary of Michigan, where could I fit in a square root? What if I went from here to here? That kind of looks like a square root. So that's done. I need a circle. If I put a center here, I bet a circle would model this piece pretty well. So that's good. I could probably even get a circle over here as well. So I got a circle. I need a line. Well, I could fit a line here. I could probably just approximate this whole piece with one big line. I could get this piece with one whole line. That should be pretty easy. I need 2 parabolas. What if I did one parabola like this? Trace it a little better, obviously, though. And then how about over here? If I made this a vertex, I could have one parabola here and then a different one over here, because one of them is kind of steeper or narrower than the other. So I got 2 parabolas. The last mandatory function is an absolute value. So what if I came over here and I made this the vertex, and I absolute valued those right there? Okay, so I hit the mandatory 6. I almost got the whole outline of the state. So I could even almost do another circle right here. I could probably just do a line here, maybe another parabola right there, maybe even another circle right here, or maybe just one giant parabola up top. That would probably work. I could probably do a line here, a line here, and a line here, a line across the bottom. So I got pretty much the whole outline, and I hit the 6 shapes. So this is going to work. If you can't do this in Smart Notebook, find something different where you can. And if you really want to do something, but you're not going to hit the 6 mandatory or the 10 plus required for an A, you can do a couple different locations. It's just going to be a little bit more work. Okay, so the next piece is going to be taking the shape and throwing it into GeoGebra. In order to do that, we want to do it to scale. We want our equations to actually fit. So we're going to go back to Google Earth, come up here to Tools, use the ruler, and I'm just kind of get a rough grid. So I'm going to click and stretch this across and get that line straight. So centimeters isn't good. Let's do miles. So it's 192 miles across. I'm just going to do the Lower Peninsula. So drop this down. Okay, so about 278 miles. So basically I need a grid of 278 by, what did I say over here? 192. So I'm just going to jot those numbers down here in Smart Notebook so I have an idea of a scale. Okay, so next thing is I'm going to go to GeoGebra. I'm going to try and get this thing scaled appropriately. Okay, once I got GeoGebra open here, something you can do is you can come up and you can click on the Move Graphics view. And if you get your cursor right on one of the axes, you can just grab and stretch this thing down. So I needed 192. So I'm going to go out to about 200 here on my x-axis. Okay, so we want to be as close to accurate as we can. And then I said I needed to go 278 up and down. So I'm going to grab the y-axis, and I need to get to about 300. So stretch that out. Okay, so that'll be pretty good. Now, you want to copy your image that you did with the snipping tool, and we're going to paste this in GeoGebra. You have to go up here to insert image from clipboard, and it'll paste it. Now it's going to be all kind of distorted, so we want this to fit basically the 0 to 200 and the 0 up to 292-ish. So what you're going to have to do is this. So before you start dragging any of these bottom 2 points down here, what we're going to have to do is create a third point so we can actually stretch this thing appropriately. So go up to new point and just kind of put it on the outside here. Now, when you right click, if you go to Object Properties and you come into Position, you got corner 1 is A, corner 2 is B, make corner 4 point C. And if you go to Color, you can shift this opacity down. So it basically makes it lighter so you can kind of see what you're graphing on there. So bring it down somewhere below 50 if you want, if that helps you. Now when we do that, we should get here. Now I can grab point C and bring it up to 292. I can grab this point and stretch it down to the origin, and you'll be able to manipulate these and get them to fit on a grid how you want. Okay, so that's pretty good there. Okay, we may be off by a little bit, but it's just a few miles. So now that I'm here in GeoGebra, go back to what you thought would fit. So I got my circles, parabolas, curves, whatever. I'm going to kind of go in order here. So I thought I could fit a parabola in here. So I'm going to create those points. I'm going to create a point right there, and then I think the parabola is going to end about right there. Now I can come up here, I can turn off these if you don't want those anymore. So points D and E, they just gave me the values. So we should be able to create an equation for a parabola between those 2 points. So I'm going to pause it and do that on a sheet of paper. So what I did is I called this equation 1. It's going to be a parabola. I'm going to use the vertex form to start. I have my vertex. I have a point on the parabola given to me by GeoGebra. So I went ahead, I did all the work. I grabbed my A value right down here. Okay. Now, when I took that and I threw that in GeoGebra and just graphed it, it doesn't fit all that well. Okay, so I'm a perfectionist, so I'm actually going to get rid of this point E and put a new point maybe down here to fit that better. So I'm going to do this again. We should be able to delete point E like that. I'm going to do it again between point D and F, and hopefully that fits better. So that fits a whole lot better. So I just kind of rewrote equation 1 parabola. I'm using points, so I guess it's not D and E anymore. It's points D and F. There's my points. I did all the work again, and that fits a whole lot better. So I like that. Now what's really cool about GeoGebra is, at first I thought we were going to have to do the project where we just had all these overlapping graphs. We can do piecewise with these, and here's how. So we're going to type function, bracket, and then I'm going to type this in again. So 0.0767 parentheses x minus my vertex squared plus 1.5, comma. Now, I only want this parabola from D to F. So if you think about piecewise functions, this is going from 1.62 to 31.02. I only want it from here to here. So if I remembered this correctly, 1.62 comma 31.02, and it'll just do a piecewise function for me, and then I can come back up here and turn off the other one, and that looks pretty good. So I typed that in correctly. You can see that there. It came up as a function now. So I can just come up to this conic and just delete that one, and that looks really, really good. Okay. Next, I'm going to pick a new point, put it right there, and I want a line in between those two things right there. So I'm doing an equation of a line between E and F. So I'm going to pause it, do the work on my paper, and I'll meet you guys in a second. So I used the 2 points GeoGebra gave me, found my slope, plugged it into point slope, distributed, and got right here. I then took that, threw it in GeoGebra, and it hit all of those, so I know that's exactly what I want. So I'm actually going to come up here, I'm going to delete that line, because I only want this line now to happen between these x values. So I'm going to come down here again, I'm going to type function, bracket, and then put the equation in. So negative 66.389x plus 2127.1867, comma, and I only want it from those x values of the points, comma 31.02, and there we go. And that fits it really, really, really well. Now what's great about this project is if you do some math wrong over here, when you graph it, you're going to see if you got the right equations. All right? So this is going to continue all the way around the state of Michigan. Okay, so 10 plus graphs if you'd like an A, 8 for a B. Make sure you hit on those mandatory 6, and then you're going to present your final solution that will look something like this. So when you're all done, you're going to tell me, what your geographic location was, obviously who you are. It's going to be a piecewise function. So we're going to say f of x, and you're going to have a bunch of equations in here. So here's my first parabola. This was equation 1, so it matched up with my work for equation 1, which you guys are going to turn in. If, and there's the x boundaries that I put in, so it actually fits. Okay, here's my equation 2. So if you go in order, this will be nice and neat to keep in line. So I did the line here between f and e. So equation 2, if, and then there's the x boundaries again. So now, if this is piecewise, if I made this a closed circle here, this should be an open circle here, because these numbers should carry over. So then the next thing I'm going to do is going to go from 31.02 up through something, and then I'll have the rest of my equations filled in here. So if you go back to the GeoGebra, so I can probably do another line here, circle there, maybe a parabola there. I was going to do absolute value here. You could maybe get one big parabola all the way across the top, circle in there, and kind of work your way all the way around, and it should flow in order here. Now the one thing before we finish this up, in the requirements, we said one of the parabolas has to be done in standard form through inverse matrices. So what I mean by that is this. So I'm going to skip ahead. I'm going to do a parabola over here. So let's pretend I got everything all finished in here. I'm going to make this my vertex, and I'm going to bring that parabola down to probably about right here. So I'm doing a parabola from G to H, but I'm not going to do it the old way. In order to do it through inverse matrices, we're going to be doing, since we have A, B, and C, we have 3 variables, we're actually going to need 3 points. So I'm going to pick another point on that parabola, probably right about there. Okay, so point I. Now, here's how I'm going to do that. So this is equation 9 or whatever it would be. I would suggest just going in order around your shape. Okay, so we're going to do it this way here. Here's 3 points. I think everybody would agree these are x's, these are y's. So I should be able to plug in an x here and here, and a y here, and let A, B, and C be my variables. So what I mean by that is this. So I can do 163.9, that's my y value, equals A times 170.44 squared, plus B times 170.44 plus C. Now, if I do that for the other 2 equations, so all I did is go plug in each of the points into this general equation for a parabola. So 132.19 is the y equals a times x squared plus b times the x times the c. Now, what this is a 3x3 system. So we could do substitution, elimination, all that stuff. We have to find the a, b, and the c values. So let's use our knowledge of matrices and put this together. So I grabbed all that information, put it in a matrix. I'm trying to find a, b, and c, and here's kind of the answers that I want. So if you think about matrix multiplication, you're going to take the row multiplied by the column. So this matches up here. This is the A, this is the B, this is the C for all of those. So I'm trying to find those A, B, and C values. So here's my A matrix, here's my X matrix, it equals the B. We know in our calculators we can do this. So throw those in. You don't know how to do a 3x3 inverse by hand. It's a whole lot of work, but that's why we have calculators. So that will tell you your A, B, and C value. You can then go throw those in here, here, and here, and then that'll be your second parabola. So you have to do one parabola this way, and you have to do another parabola with the way we've been doing it before. If you have multiple parabolas, this way is obviously a lot quicker, but we just wanted to tie that into our knowledge of matrices as well. So have some fun with this project, and let's see what you guys can come up with.